Okay, James, so there's going to be a couple things that you'll need to remember in order to be able to complete this algebra and geometry overlap unit. So we're going to review a couple things for this lesson. So the first thing I want you to remember is midpoint. And if you remember, the midpoint is the average of the x and y coordinates of 2 points. So the actual formula for that is x1 plus x2 over 2, which is just the average. You know, you're adding the two of them and then dividing by the number of numbers. And then same thing for the y's, y1 plus y2 over 2. That's the midpoint formula, so let's do a quick example. Find the midpoint between 2, -4, and 5, 7. So to do that, we're going to average the x's and the y's. So I'm going to do 2 plus 5 over 2 and -4 plus 7 over 2. And that is going to give me a midpoint of 7/2 for my x. And if we add those together, we get 3/2 for my y. So there's my midpoint. So that's about all that you need to remember for midpoint. That's going to be really important when we do things like find the equations for medians or mid-segments, and we'll do a little bit of that in a minute. So here we go. Next thing you need to remember is the distance formula, which we just did not too long ago. So just a quick refresher on the distance formula. And if you remember, it comes from the Pythagorean theorem, so it looks very similar to it. So the distance formula is d squared equals the difference of your y coordinates squared plus the difference in your x coordinates squared. And if you remember, one of those gives you the height of a sketched triangle, and one of them gives you the width of a sketched triangle. So it's kind of like the two portions of a right triangle. So this would be like the difference or the change in our y's, and this is like the change in our x's if we're trying to find the distance between points A and B. So that's where these come from, and then this is similar as if we were squaring this side of the triangle. So this is like a squared in the Pythagorean theorem. This is like b squared, and then the distance would be like our hypotenuse, or c squared. So that's where that comes from. So let's do a quick example. So if you want to find, let me scoot this paper up. Hopefully I'm not making you too dizzy. If you want to find the distance between 3, 0 and -4, 8, we would just plug those into our distance formula up here, and we can find the distance. So we're solving for d. So we're going to take the difference of our y's. So I'm just going to do 0 minus 8 squared plus the difference of our x's is actually going to be 3 plus, because minus a negative gives us the positive, 4 squared. If we simplify those, we get d squared equals 64 plus 49. And if we keep simplifying there, we're going to get, well, I don't have my calculator with me, so add those up, and I get 3, 1, 7, 113. Okay, d squared equals 113. And then if you remember, a special thing about solving the distance formula is that we're going to square root both sides to get rid of the squared. square root, square root. However, I am not going to put the plus or minus on this square root because it's a distance and distance can't be negative. So I'm just going to say d equals the square root of 113. I'll just double check myself and make sure that 113 cannot be divided by any perfect squares. I don't think it can. I'm pretty sure it's prime. So this is my answer.